Hello, Algebra Scholars. This is the second half of section 6.3, and it's on finding least common denominators. Just a quick note here that an LCD is basically the same as an LCM. We just use LCDs when we have fractions, and we call it an LCM when we don't have fractions. So we'll use them interchangeably for the most part. I mean, we should try and use them in their right context, but I'm not going to fuss too much about it. So to find a least common denominator, you have to start by writing the prime factorization of each denominator. Then all you have to do is choose the greatest power of every different factor that occurs. So here's an example. 36x squared y cubed. Its prime factorization is 2 squared times 3 squared times x squared times y cubed. And 24xy to the fourth z is 2 to the third times 3 times x times y to the fourth times z. So we would say the least common multiple. So we're looking at every different factor. Now many of the factors here are actually common. 2's are common, 3's are common, x's are common, y's are common, but z's are not. We really don't care if they're common or not. So we're just going to choose the largest power of every different factor. So for the 2's, we'll choose 2 to the third. For the 3's, we'll choose 3 to the second. For the x's, we'll choose x to the second. For the y's, we'll choose y to the fourth. And for the z's, well, we'll just choose z, or if you like, z to the first. So the least common multiple of the two expressions that are given, 2 to the third is 8, 3 squared, so 72 x squared y to the fourth z. And in simple language, a least common multiple is basically the smallest thing that both of these guys will go into evenly. Let's try a harder example on the next page. Finding the LCM of binomials and trinomials, we follow the same procedure that's outlined on the previous page. We first need to factor everything, and x squared minus 4 factors into x plus 2, x minus 2, and this trinomial factors into x plus 2, x plus 5. And so the least common multiple will take the greatest power of x plus 2, which is x plus 2, the greatest power of x minus 2, and the greatest power of x plus 5. So this is the least common multiple for example A. In example B, this first guy factors into x minus 3x plus 1. I'm not showing my factor sum charts here. The second trinomial factors into 2x plus 1 and x plus 1. And the least common multiple is x plus 1, x minus 3, and 2x plus 1. In this final example, we're going to first find the LCD, and then we're going to write equivalent fractions that have the correct LCD. So let's do our LCD work right here. Prime factorization of 12x is 2 squared times 3 times x, and the prime factorization of 8y squared is 2 cubed times y squared. So the LCD is 2 cubed times 3 times x times y squared, which happens to be 24xy squared. So what we're going to then do is we're going to rewrite these fractions with the LCD as their denominator. I'm going to draw a line here from the first denominator to our new denominator, and we're going to ask the question, what did we multiply by our first denominator to get the new denominator? And the answer is 2y squared. And if we multiplied the bottom by 2y squared, we have to multiply the top by 2y squared. And 5 times 2y squared is 10y squared. And then we're going to ask the same question here. How did we get from 8y squared to 24xy squared? What did we multiply by? And the answer is 3x. And if we multiply the bottom by 3x, we have to multiply the top by 3x. So we have written equivalent fractions. These fractions are the same as the original, but they now have the correct common denominator. In our last example here, x squared minus 1 is x plus 1, x minus 1. X squared minus 3x plus 4 is x minus 3x minus, x minus 4. Nope, scratch all that. Hold on, wait for it. I'm going to have to change the original problem here, my friends, to minus. Change the original problem here. That doesn't want to change. We'll change this to minus 4. Okay, that's going to allow us now to factor this, into x minus 4 and x plus 1. And so the least common denominator is x plus 1, x minus 1, and x minus 4. So, let's see, our first fraction was this, and our second fraction was this. And now I want both fractions, x plus 1, x minus 1, x minus 4, x plus 1, x minus 1, x minus 4. How did we get from this denominator to our new one? We multiplied by x minus 4, and if we did it to the bottom, we have to do it to the top. And then over here, x minus 4, x plus 1, we multiplied by x minus 1. So this new equivalent fraction is 3x times x minus 1. And that's how you write equivalent fractions with the least common denominator. That's it for section 6.3.